Assalamualaikum. This video is about case study of polluted river in Malaysia, and our selected river is Kuantan Bauxite site, which is located in Kuantan. And this video will be presented by me, Muhammad Umahya, Syabir Akif, Zikri Iqbal, and Razif Naim, and Zafran. Our agenda is firstly introduction to the case study, second major sources pollution, third impact of polluted river, fourth community of global initiative, and the fifth innovative solutions. Bauxite is the primary ore for aluminium production. In 2014, Indonesia, a major bauxite supplier, imposed an export ban to develop its domestic processing industry. This created a supply gap, leading to a surge in bauxite mining in Malaysia, particularly in Kuantan. To meet the demand from China, Malaysia bauxite export increased dramatically from over 200,000 tons in 2013 to nearly 20 million tons in 2015, making it the world top producer and accounting for nearly half of China bauxite supply. Next is case study identification, which is Kuantan bauxite disaster. Trend of water pollution in Sungai Kuantan between 2012 until 2018. Sungai Kuantan, located in Pahang, Malaysia, has experienced notable fluctuation in water quality over the years, particularly concerning concentration of toxic metals such as arsenic, AS, and mercury Hg. A study conducted between May and October 2012 revealed the following concentration. Dissolved arsenic ranged from 4.650 to 36.894 microgram per liter. Dissolved mercury ranged from below the detection limit to 0.011 microgram per liter. Particulate arsenic varied from 0.650 to 86.087 milligram per liter. Particulate mercury varied from below the detection limits to 5.873 mg per liter. This picture is taken from internet, which is show the condition of Kuantan bauxite disaster in Kuantan between 2012 until 2016. Several governments, bodies and agencies were responsible for overseeing and addressing the environmental issue arising from the bauxite mining activities. These three is the responsible authorities, which is Ministry of Natural Resources and Environmental, Pahang State Government, and Department of Environment.
In the next topic, major sources of river pollution. Firstly, mining waste. Sediments and mining waste run off into rivers. Then, heavy metals in mining waste react with oxygen, forming distinct color and toxic compounds, turning the water reddish in color. This pollutant made the river unsuitable for aquatic biodiversity, leading to its decline. Next, transportation of materials, where truck carrying bauxite create spillage and dust. This spillage often wash into rivers, carry sediments that reduce water quality. Thus, the sediments alter soil composition, reducing fertility and affect pH levels, leading to disrupting aquatic ecosystem. Lastly, erosion and deforestation. The removal of topsoil and vegetation expose land to erosion. This leads to direct runoff of pollutants from mining site into rivers. Natural buffers such as forests which filter out pollutants are also lost. Next, impact of polluted river. Firstly, environmental impact. A significant loss of aquatic biodiversity as many species cannot survive in polluted waters, destruction of habitats, and cause water quality decline. After that, economic impacts. Reducing income of fisheries activity. Tourism activity in the country will be affected since it is restricted to prevent tourists from affected by the pollution. Lastly, impact on human health. People are exposed to skin and waterborne disease. Other than that, long-term exposure to toxic chemicals in polluted river puts communities at risk of chronic illness.
We move on to our next content, which is potential integrated mitigation measure. There is three type of mitigation measure, which is first one is physical mitigation measure. For the second one is chemical mitigation measure, and the last one is biological mitigation measure. We begin with physical mitigation measure, which focus on soil stabilization, waste management, and water protection. For short term, we can install sediment trap and barrier. Installing silt fences and sedimentation ponds prevent bauxite-laden runoff from contaminating water bodies. Using geotextile mats and cover crops, stabilize exposed soil for erosion control. For water containment, we can secure impermeable tailing ponds prevent groundwater contamination. For long-term strategies, we can consider rehabilitation. We can backfill mine areas, reshape land, and plant native vegetation to restore ecosystem. We can also implement land zoning and GIS-based monitoring to track changes in land use and water quality. Next, we look at chemical mitigation measure to address pollution at the chemical level. We can neutralize acidity using alkaline agent like lime to remove heavy metals. We can also consider flocculation. Coagulant like chitosan help settle sediment in water bodies. For long-term strategies, we can use biochar or compost to immobilize heavy metals in soils. We can also construct wetland treat pollutant over the long term for the leachate treatment. Now, let's discuss biological mitigation measure which use natural process for recovery. For the short-term action, we can create wetland with aquatic plant to absorb heavy metals and use biofilter to trap sediment. Other than that, we can introduce microorganisms to break down pollutant and reduce metal toxicity. For the long-term strategies, we can plant native trees to stabilize soil and enhance water infiltration. We can also engage communities in eco-friendly farming to ensure land remain productive. Other than that, we can use fungi to break down pollutant and restore soil and water quality. In conclusion, a combination of physical, chemical, and biological measures provide a comprehensive approach to mitigating mining impact. This strategy helps restore ecosystem, protect water quality, and support sustainability land use.
Our river, the Creative Public Awareness Campaign. So our project focus on the Creative Public Awareness Campaign addressing the Kuantan Bauxite disaster in Sungai Balok and Sungai Tonggak. The theme is restoring our rivers, protecting our future. Our main objective is to educate the public about environment damage and health risks caused by improper bauxite mining. We identify key targets audience including local community, industries, policymakers, and students. The campaign highlights environmental issues like sedimentation and biodiversity loss, health risks such as heavy metal poisoning, and costs for sustainable mining practice. To reach this audience effectively, we propose using various creative tools. First, we will develop visual content such as infographic, poster, and short video to illustrate pollution trends and impacts. Next, we plan to organize clean-up events and workshops to engage local communities and industries. Finally, the digital outreach campaign on social media will include hashtags like Restore Kuantan Rivers and interactive posts to increase engagement. Through this campaign, we aim to increase public awareness and encourage greater community involvement in restoring polluted rivers. We also expect a stronger accountability from industry and support for sustainable mining practice, ultimately contributing to cleaner water and a healthier environment.
So now, we will start with innovative solution for water pollution control. As had been mentioned before, between 2014 and 2016, a rapid increase in bauxite mining in Kuantan, Malaysia led to an ecological crisis. High global demand for bauxite, essential for aluminium production, caused severe environmental degradation, particularly affecting water sources. In 2016, the government implemented a temporary mining ban to curb this disaster. However, after the ban was lifted in 2025, the threat of contamination re-emerged. This situation underscored the urgency for sustainable, efficient solution capable of mitigating such environmental disaster, which brings me to our first innovation. So, for our first innovative solution is hybrid reactive barrier. The hybrid reactive barrier is designed to tackle industrial pollution in water sources by combining advanced filtration, chemical treatment, and stabilization method into a single system. The barrier comprises three key layers: which is for the first layer is sediment filtration. It is made by recycled plastic like PET flakes or mesh to trap sediment, debris and bauxite particles. Second layer is reactive zone. This middle layer made from crushed glasses, steel shaving and limestone to neutralize harmful chemicals and heavy metals. The third layer is stabilization and outlet. Recycled rubber chips are used here to stabilize the water flow, prevent channeling, and improve overall performance. And prioritize eco-friendliness by utilizing recycled material sources from local recycling center. It also addresses various pollution challenges from sediment control to heavy metal removal. So this is our sketch of reactive barrier. So for our second innovative solution is integrated real-time monitoring system. To complement the physical filtration process, we have integrated a real-time monitoring system powered by IoT technology. This system ensures the barrier operates at peak efficiency at all times. This system also includes inlet sensor to detect water quality parameters such as pH, turbidity and heavy metal content as water enter the barrier. Also, we have embedded sensor in each layer to monitor performance to detect and predict potential inefficiency. Also, we have outlet sensor to confirm that treated water leaving the barrier meets strict environmental standard. The data collected is relayed to a centralized network, enabling continuous monitoring, real-time alerts, and in-depth analysis. This proactive management ensures immediate corrective action, significantly reducing risk. So, this is our sketch for integrated real-time monitoring system. For our third innovative solution for water pollution control is floating treatment island. Floating treatment island or FTIs offer natural yet innovative approach to combating water pollution by utilizing plants and microbes. FTI function on three principles: pollution reduction. The plant absorbs heavy metals and harmful nutrients while their roots host microbial biofilms that decompose organic matter. Plant selection. Native water purifying plants are chosen for their ability to thrive in polluted environments. Next, platform design. The floating base, made from buoyant recycled materials, provide a sustainable and efficient support system. Like the hybrid reactive barrier, FTIs are also constructed using recycled materials collected locally, ensuring accessibility and sustainability. So, this is our sketch of our floating treatment island. In conclusion, water pollution remains one of the greatest challenges of our time. However, with innovative and sustainable solutions like the hybrid reactive barrier, the integrated real-time monitoring system, and floating treatment island, we have the tools to make a meaningful impact. This solution demonstrates the power of combining engineering, technology, and nature to create a cleaner, safer environment for future generations.